So I just read, I'm on chapter 2 now of Machine Learning by Tom M. Mitchell. And the topic of the chapter is the name of the chapter is Concept Learning and the General to Specific Ordering. They give you in the chapter, they give you make sure I'm on mute here. Yeah. In the chapter, they give you an example of the concept that you want the program to learn. So, for example, what days does my friend Aldo enjoy his favorite water sport? And you can define, it's a Boolean value. He either enjoys it, yes, or he doesn't enjoy it, no. And it's based on 6 attributes. It's based on, it's based on the sky, so whether it's sunny, rainy, I don't know the other ones, air temperature, humidity, wind, water, and forecast. And then the last attribute is whether he enjoys the sport or not, and that's the one we care about. They introduce concept learning because this is a concept as a search. So you're searching through what they call a hypothesis space. And I found a more simple example to explain, more simple than what days my friend enjoys his favorite water sport, is what is a swan? And you can describe a swan through attributes. You can say that it's big, you can say that it's white, you can say that it is on water, etc. They go through this concept of when you're searching, it's a search, right? So you're trying to go through all the possible hypotheses and find the one, or find the space, or the one hypothesis that will work regardless of what you like through the training examples. So these are the hypothesis they're talking about guessing. So if you are trying to explain this to a person, the way I would do it using the swan example is that you want your hypothesis to be specific enough that it selects, that it can identify whether something is a swan every time. But you don't want it to be too specific or too general. So what do I mean by that? For example, if you say, I had it here. If you say, for example, if you say all white birds are swans, that's a too general of a hypothesis, right? Because you have geese that are white, you have doves that are white, etc. Right? So that's too general. We want to be a bit more specific. But you don't want to go too specific. So for example, if you say all big white birds that swim on water and have exactly 48 feathers are swans, that's too specific, because if you specify it down to the 48 feathers, you're going to come across swans that have more or less than 48 feathers. And by that hypothesis, it would classify those swans as not swans. so you want something in the middle, and your algorithm, your program needs to learn how to do that. So that they introduce something that's called general to specific ordering. Basically, you go from, in no specific order, you have this whole space of possible hypotheses, right? You have the space where it's they define an instance, right? So basically, any of the attributes, whether it be color, size, habitat, whether it's on water or not, that specific instance, there's a number of different ways you can do that. So you can have an instance where it says the bird is white, the bird is big, the bird is lives on water, the bird has a long neck. Let's say those are your 4 attributes, right? Neck, whether it lives on water, whether it's size, and color. If you're using those 4 attributes, there's a bunch of different combinations within that. You can also say that it's not, you don't necessarily have to define every one of those attributes, right? So for instance, it might be enough, I'm not saying that it is to classify it as a swan, but it might be enough to just say it has a long neck, it's white, and it lives on water. You might not necessarily have to say about the size. And the way that's identified is it puts a question mark under size. So we don't care what the size is, as long as these other 3 things are present. And that's more general than specifying that the swan has to be big. So, for instance, that would be the most general hypothesis, is everything's question marks, right? That it doesn't matter what it is, it's definitely a swan. Conversely, a dead hypothesis would be if all of those were thetas. So they define something as it doesn't matter, or regardless of what it is, it's definitely not a swan. So for example, if we put a 5th attribute in there, let's say we put an attribute that tells you what kind of I don't know. I mean, you could put another. If you're saying it doesn't, that the whole hypothesis is dead, regardless of what that attribute is. So it's basically saying, like, if you put a theta under swan, if you put a theta under swan, or sorry, a theta under size, you're saying regardless of whether it's small or big, whatever one you choose, this is definitely not a swan. Which essentially makes all the anything with a theta, I believe, essentially makes it a negative hypothesis. It will classify anything with that as not being a swan. So, which I think is not really in the list of hypotheses, but they include it anyways, right? You would automatically get rid of that anyways, anything with a theta under it, because it's not, yeah, I think I have that right. So there's that. So you're trying to minimize the hypotheses where you have the general to the most specific hypothesis. And you keep narrowing that down until you get to one hypothesis that correctly identifies all the instances belonging to the training examples correctly, whether it's not a swan or it is a swan. So that's the idea. Then they go over this concept of positive and negative examples. And basically what that is a positive example is something where it classifies it as a swan. A negative example is it classifies something as not a swan. That's, pretty simple. So the question mark versus the theta or slash through the zero is super strict, whereas the question mark is very flexible. The question mark means I don't care about this attribute. It could be any value, doesn't matter. I'm going to classify this as a swan. The zero with the slash, which I believe is theta, is very strict. So it doesn't matter what value you put in there, I'm not classifying it as a swan. And then they go into partial order among hypotheses. So this general to specific relationship between hypotheses behaves like a partial order, meaning we can compare hypotheses to each other in terms of generality. So you can say that something is more general than something else. Like if my hypothesis is big white birds, right? And then, a couple other of the other attributes. That's more specific than big birds, right? So big birds is more general. So if you had, the difference between those two hypotheses is everything that's in the more general hypothesis, for instance, big birds. You would get a heron, you would get an emu, you would get an ostrich, you would get a bunch of birds. They're going to all that general hypothesis is going to classify everything as a swan. A hypothesis that is a bit more specific, big white birds, would just classify swans, probably geese. I can't think of any other big white birds. Would classify those as swans. So that's what they mean with that. That's pretty much the first 5 pages of chapter 2. Hopefully I explained that to myself correctly. Thanks for the journey of watching this. If you watched it to the end, if you didn't, no worries. Hopefully that helped. Hopefully it helped me.